Good day, ladies and gentlemen. I welcome you again to Simplified RSA, the guys who makes it look easy. And we are your number one learning channel in the whole world. I'm Mr. Maimane. And then for today, we'll be looking at physics. The question is from a past paper of grade 12 students, but it is also relatable to grade 11 students as well. So it is physics, like I said. We're going to go straight to the question without wasting time. So the question reads, a block A of mass M is connected to block B of mass 7.5 kg by a light inextensible rope passing over a frictionless pulley. Block B is initially held at a height of 1.5 meters above the ground, while block A is initially stationary on the ground. If block A is initially stationary, it means also block B is also stationary at that position that it was held at, as shown in the diagram below. And then we have more information that states that block B is released. Or when block B is released, it moves vertically downwards and strikes the ground with a velocity of 3.41 meters per second. And we are told we can ignore the effects of friction. And then for 2.1, we have to show by means of calculation that the magnitude of acceleration of block B was 3.88 meters per second squared, while block B was moving vertically downwards. The way the blocks are hanging, most students, they fall for... Oh, by the way, the reason why I selected this question is because I've realized that a couple of students were struggling from the information, and that's the criteria that we use when we're selecting a question. We select a question based on the amount of students who struggle from that question, such that if we share the information, it will save someone like you to can prepare for whatever exams that you are facing with, whether should it be physics or mathematics. So don't forget to subscribe, and don't forget to follow us in all our social media platforms. So now, to calculate the acceleration, we can tell that in this case, we don't have a projectile motion situation, because block B was held at a certain height. The moment it was released, that was not really a free fall of some sort. So now it means we have to have a certain acceleration that it was accelerating at. But in this case, we are given that we should have an expected value. So whenever you are expected to show, I feel like you have to make sure you get the question right, because you know what should be your final answer. So we just have to make sure that our calculations, whatever we get, has to be exactly as what they wanted us to show. So what the acceleration that we're going to calculate here, we must get it to be 3.88 meters per second squared. If not, then we have done something wrong. Let me show you how we do it. So now, to get the acceleration that we have to show, we can tell that we're going to have to use equations of motions, because both the blocks A and B, if we have the x-axis here, we have the y-axis here according to the direction of the motion, we can tell that both the blocks are moving in a vertical motion like that. And our choices of equations of motions that we have, we know that the first one would be change in y is equals to v initial change in t plus 1/2. I would say acceleration change in t squared. Normally, whenever we are looking at vertical motion, we would normally assume the acceleration to be a gravitational acceleration g. But this one is not really a free fall, because block B was released after it was held by someone in some type of way, such that when it is dropped, it moves at a specific acceleration, which we have to determine in this case. And that acceleration, it should be 3.88 meters per second squared if we do our calculations right, based on the question that we are given. And the second equation of motions that we can look at is, Vf squared is equals to, for final velocity, is equals to V initial squared plus 2a change in y, because it's a vertical motion. And then the next one would be Vf is equals to Vi, V final is equals to V initial plus acceleration change in t, and then the other one would be change in y is equals to vf plus vi for v initials over 2 times change in t, like that. And now, to get the acceleration, I encourage that you get all the information you have regarding the block in question. So the information we have regarding block B, because for you to use any of these equations of motions, you must have at least three variables that you know in order to determine the fourth one, because all the equations, each one of these equations is composed of four variables. For example, 1, 2, 3, 4. Like you have to have, it has four unknowns. So you have to have three knowns for you to determine the one unknown. So given that change in y, change in t, final velocity, initial velocity, and acceleration, what information do we have about block B, the data that we have for block B? Obviously, the acceleration we don't have because it's the one we have to calculate. The initial velocity, block B, it was held initially at the height of 1.5 meters above the ground, while block A was initially stationary, meaning there was no movement between the two blocks. So the initial velocity is 0. The final velocity is when block B is released, it moves vertically downwards and strikes the ground with a velocity of 3.41 meters per second. That means our final velocity is 3.41. We don't know the time it took block B to strike the ground, but we know the height which block B was at. So we know that change in y is 1.5 meters. Having the three known variables, which is change in y, v final, and v initial, it is easy for us to determine the acceleration in question. And from our choice of equations here, we can tell that the best equation to use is the second one, because we have the final velocity, we have the initial velocity, and we have the change in y. We just have to get the acceleration. Now, let's go. Now, because you have chose the equation that you want to use, normally students will go ahead and substitute the values in the equation to get the acceleration A. But here's the thing, I advise that instead of substituting in the beginning, it is best that you brag with your mathematics if you can. Rather, we make acceleration subject of the formula first, and then we're going to substitute after. That is the best way of using your equations of motions. So now, this is the same as 2a change in y. It's equals to vf squared minus vi squared, if I put it like this. Therefore, to get the acceleration, I can divide by 2 change in y both sides of the equation because it's just the maths. And then the 2 will cancel the 2, the change in y will cancel the change in y, such that acceleration is going to be vf squared minus vi squared all over 2 change in y. And mind you, in this scenario, it is advisable that you must choose your scenarios. Either we choose the downward position to be positive, or we choose the upward position to be positive. So in this case, I'm going to choose down to be positive. If I choose down to be positive, it means I will substitute my my height, or rather the position, as a positive value, such that if I substitute everywhere, the final velocity is 3.41 squared minus the initial velocity, it was 0 squared, all over 2 change in y is 1.5 meters. And then from here, it looks very much neat. If you wouldn't be wrong if you can substitute from here. But look how beautiful it is when you just solve the equation first and then you substitute after. And then the value that we're going to get here is going to be, and then the value that we get, if we round it off, is going to be indeed 3.88 meters per second squared, whereby it has to be exactly the same as from the question, like I said. So 3.88 meters per second squared is the velocity at which block B strikes the ground after traveling 1.5 meters. Um, the second question, 2.2, I believe most students will take this mark home. We have to draw a labeled free body diagram showing all forces acting on block B immediately after it was released. So all the forces when it was in the air somewhere there. Um, Easy question, this one. This is how you approach it. So in a vertical motion, I'm going to show the mass there. In a vertical motion for block B, if we are told to ignore the effect of air or friction, there are only two forces acting on that block, um, which is the weight of the block as well as the tension, which is the rope, that rope that is tied to the block, that is tied between the two blocks. And the free body diagram, you're just going to show a diagram like this. And then after, you must also name your forces. That T is the tension force. And you must also show that W, you can either say weight or gravitational force. And then you get your full 2 marks like that. Free body diagram, this is how you represent it if you want to get the full mark. Some students prefer to label the forces from there. I think it's also right, but as long as you name your forces accordingly. So now, for question 3, you are required to state Newton's second law of motions in weights. A question like this doesn't really worry me because I know that whenever someone is preparing for an exam, it's far much easy to memorize the the definition of something as it is, and then some they even sing it out loud because these things they are not delivered in our language, and sometimes it would be hard to even grasp that meaning of that thing in language. But I always say, to understand the definition in most cases when you are doing physics, most definition they explain what the formula is about. So if you know the formula of Newton's second law, it would be easy for you to describe or define the formula in words just by looking at the formula. So this is what I mean. If you had forgotten the memorization of Newton's second law, you must look at it like this. We know that Newton's second law is the equation for Newton's second law is F net is equals to ma. Now, the definition is that when a force is applied to an object, the object will move with an acceleration that is directly proportional to the force and inversely proportional to the mass. That's what the definition would say. And you can see here that acceleration is directly proportional to the net force. Also, acceleration is inversely proportional to the mass. So I repeat, when a force is applied to an object, the object will move with an acceleration that is directly proportional to the force and inversely proportional to the mass of that object. That's what you can say regarding Newton's second law. Now, the most interesting question is the following question, 2.4. We have to calculate the value of mass m by applying Newton's second law to each block while they are in motion. You see now, they have given you a hint such that you're going to somehow involve the two blocks, because you can also see that they are emphasizing by each block because it is in capital letters. We wouldn't be able to get the mass m without involving both the blocks because they are tied by the same tension, you see. But anyway, it's going to make sense as we calculate it. Look at it like this. For block A, we don't know the mass. For block A, we don't know the mass. But for block B, we know that block B is 7.5 kg. These are the free body diagram for both, for the blocks. But we know that the tension between the two is the same. We have a tension here, we have a tension here, and we know that they both experience the gravitational force, which is the weight. Now, in this case, if I can calculate the tension of block B, if I can calculate the tension of block B, I know that the very same tension is going to be the same tension force for block A, you see. And then that's going to help me to get the acceleration. So I will say that for block B, I'm still choosing downwards to be positive in this case. I'm choosing the downwards to be positive. So for block B, I know that F net is equals to MA, right? Now, if I'm choosing downwards to be positive, I'm choosing that case when block B is going down. So if it's going down, meaning the bigger force in that case would be the gravitational force. So I would say W minus the tension is equals to MA. But I know that W is mg minus the tension is equals to MA. And then here I want to calculate the tension force. Like I say, you can go ahead and substitute from here. You can get your full marks because you know your mass is 7.5. You know your gravitational force will be 9.8. I'm going to take a positive one because I'm taking down to be positive. If I was taking up to be positive, and then G would be minus 9.8. And then I know the acceleration, it was calculated, it's 3.88. That is the acceleration which block B strikes the ground at, and the mass is the same. But allow me to use my mathematics to make T subject of the formula. So in this case, I would have minus T is equals to mg, minus T is equals to MA minus mg if I take mg to the other side. But since I have a negative here, I want it to be positive. I would say T is equals to mg minus ma, because I have to divide by negative throughout. But then I'm going to take m as a common factor. Therefore, I would have g minus a, like that, such that to get the tension, I would say the mass for block B is 7.5 kg, and then my gravitational acceleration is 9.8 minus, since I took downwards to be positive, I'm going to write it as it is, 3.88 meters per second, and then I calculate the tension like that. If I punch it on a calculator, I will get the value of, I get 44.4 newtons. That's the tension T. So if this tension is 44.4 newtons, I know also this side is going to be 44.4 newtons, you see. Now for block A, I know that again, F net is equals to MA. That I know. Before I proceed, I want you to understand that based on my choices, I chose downward to be positive because block B is traveling downwards. But as block B is traveling downwards, it means it is pulling block A upwards like that. So the direction of block A is going up while block B is going down. So now in this case, you can see here, I chose W minus T. I said the weight is bigger than the tension because it is pulling the tension down. But in this case, I would say now T. Okay, let me use a different color there. In this case, because now M is going up, I will say T minus W is equals to MA, as it is like that, because now it is moving upwards. Therefore, T minus mg, because I know W is mg, is equals to MA. If I write this in terms of the tension, I would have T is equals to mg plus MA, you see. But now I'm looking for the acceleration M. I could substitute all the values, but I enjoy playing around with the mathematics and substitute everything after. So if I rewrite this, I would have mg plus ma is equals to t because I know the tension. But the acceleration with which block B hits the ground would be the very same acceleration with which it is pulling block M after it hits the ground as well, such that here, if I take out my common factor M, I'll be left with G plus A is equals to T, whereby if I divide both sides by G plus A, I would have that M is equals to T over G plus A, like that. And from here, it is easy to tell that M is going to be the tension, which is 44.4 newtons, all over 9.8 plus 3.88 meters per second. And then to get the actual mass there, I would just say it's going to be 3.25 kg, which makes perfect sense, because if mass B is 7.5 kg and mass M is 3.25 kg, it means this mass is bigger to pull this mass up when it is dropping downwards. So that's it for 3.2.4. Now, I want you to participate. I want you to try 2.5. 2.5, we are required to calculate the maximum height above the ground that was reached by block A, and it was being pulled up. The maximum height. At some point, let me give you a hint. At some point, we know that when block B is going down, as it was 1.5 meters above the ground, as it pulls down and block A is going up, at some point, block A will cover the very same 1.5 meters. But somehow it shows that it means it went extra high. So now we need to know the highest, the maximum height, the highest block A has went. Please attempt the question, leave your answer on your comment. Leave the answer on the comments. We just want to see how can we do it. And then later on, I'll then come with an answer as well. But then attempt this one. Try to see if you can get the maximum height that was reached by block A, and then leave me your answer on the comment. Thank you for watching. Don't forget to subscribe as well and follow us in all our social media platforms. And if you are interested to inquire about our private lessons, feel free to send us an email or a WhatsApp. Here's the contacts here. I'm Mr. Maimane, and this is Simplified RSA. We are the guys who makes it look easy. Until next time.